So this is a typical capture-recapture problem. In the first capture, 75 elk were tagged. So 75 divided by the number in the herd would be the percentage that have tags. We don't know the total number in the herd that have tags. The recapture, we recaptured 100 elk and 18 of them had tags. So the 100 elk that were recaptured, that's like your N. So N is 100, and P is the percentage of the elk that said, yes, we have tags. That's 18 out of 100. So there are your N and your P values. That's 0.18. And then from those two, we're going to calculate a 95% confidence interval for the proportion of elk in the herd who are tagged. So that is going to be our M minus 1.96 standard errors divided by N, and the mean plus 1.96 standard errors divided by N. That's going to give us a range of percentages, something like 10% to 20%, whatever. That's going to be the percentage of elk that have tag, or the 95% confidence interval for the percentage of elk that have tags on them. So we go ahead and calculate our mean is equal to N times P, which N times P is just going to be 18 in this case, and the standard error is going to be the square root of N times P times 1 minus P. So that's 100 times 0.18 times 0.82. So we'll go ahead and go to the calculator from here. The 18, well, I already have stored 18 into M, and then the square root of N, which is 100, times P, which is 0.18, times 1 minus P, 0.82. I'm going to take that value and store it into E. So now I have M is 18 and E is this number, approximately 3.84. I can do M minus 1.96 E divided by N, where again N is this 100. So in parentheses, M minus 1.96 standard errors, in parentheses, divided by 100. So that should be this number here, and that turns out to be about 10.47% of the elk have tags. I'm going to store that into A, alpha A, so I'm going to need that number later on. Then we're going to second recall twice, to take this expression and change that minus into a plus. So then now I can do M plus 1.96 E divided by N, and I'm going to take that value, about 25.53%, and I'm going to store that into B. So I've answered part B of this question, which find the 95% confidence interval for the proportion of elk in the herd who are tagged. So that is somewhere between 10.47% and 25.53%. 0.53. So there's our percent, our 95% confidence interval for the percent of fish that are elk that have tags on them. So now to find the interval for the population of elk in the herd, we're going to take our total number that actually have tags, which is 75, and we're going to go 75 divided by the population. I'm going to set it equal to this number and then this number and solve for x. So if I set it equal to A in my calculator, which is this 0.1047 number, and I want to solve for x. So if I multiply both sides by x, I get 75 is equal to, I'm going to call this A times x, divide both sides by A. X is going to equal 75 divided by A. So my calculator, if I take 75 and I divide that by alpha A, that's going to be a number of elk in the herd. So my upper estimate for the number of elk in the herd, 716 point, I'm just going to round that to 716.3. So 716.3 is going to be my upper. And then when I set the 75 over x equal to this number here, the 0.2553 number, which is B, then x is going to equal 75 divided by B. And so if I do that in the calculator, 75 divided by B, that gives me my lower number of 293 point, I'm going to round that to 293.8 for now, 293.8. Now, when we're talking about number of elk in the herd, these, we're not going to round to the nearest tenth of an elk, we're going to round to the nearest whole elk. But if we have, this is our 95% confidence interval, I mentioned that you always want to round these into the center. So even if this were 293.2, we'd still round it up to 294. And if this, even if this were 716.9, we'd still round it down to 716, because our 90, if these are the endpoints of our 95% confidence interval, then our confidence interval is going to be around the 294, outside of the 294 and the 716 number. So there is our 95% confidence interval for the population of elk in the herd.